In this lesson, we are going to go over the second part of the mean proportional theorem, and this is going to be called the leg rule. So we already went over the altitude rule and how to identify it, but we still want to make sure we understand what's going on here. So just remember that an altitude of a triangle is a segment drawn from the vertex that is perpendicular to the other side. And also remember that when this altitude is being drawn down to the hypotenuse, so if we have a right triangle, and our right angle is up here, our hypotenuse would be down here. We want to make sure that we know this. Hypotenuse, and then the other two sides, this is one leg, this is another leg. So you want to make sure you remember this, because if you don't know the sides of the triangle, then it's going to be really hard to apply these theorems. So again, what's happening is we're going from the vertex down to the hypotenuse, making an altitude, and we are making a bunch of similar triangles. So we need to know for this rule, in the formula, there's this word projection. Now we need to know what a projection is and how to find the projection. So what a projection is basically like, think about a projector, literally. Like if you have your projector here, right, it's going to be going out this way, and the projection is going to be somewhere on the screen over here, right? If your projector was here, facing downwards, your projection would be somewhere down here, right? So think about like drawing an arrow down from where something is. Now, your projections for right triangles are always going to come from legs. So when you guys are making your diagrams, you should be drawing this in your notes, and you should also use different colors if you have them to highlight. For example, we should be highlighting this leg in red. And again, usually when we're talking about legs, it's always of the larger triangle. So this red side is a leg of the largest right triangle here, and the projection, we can just draw an arrow straight down. The projection of leg AC is going to be the entirety of this side AD. Now in blue, we have the other leg of our triangle, and the projection of leg CB, we can go straight down. The projection of leg CB is going to be this segment DB here. So make sure you understand, and we never mix, right? Like the projection of this red leg is never going to be all the way across down here on the other part of the hypotenuse. It's never going to happen. So just recall, I'm not going to go over the longer way like I did in the other video, but you can always fall back on your knowledge of similar triangles to help you solve. On the exam, if you forget the formulas, you can always fall back on your knowledge of similar triangles to solve these, right? It would just involve drawing all three of these separated triangles in the same orientation, putting your values in, and then making your proportions. But we're just going to go over the easier way, the shorter way, because this is going to help you save some time. So recall, you want to write the leg rule down and you want to write the formula. You also want to make a note for yourself that the hypotenuse and legs that we're talking about are always from the largest triangle. So in this case, the largest triangle is this one here that I'm highlighting, triangle ABC. So obviously when we're talking about the hypotenuse, we're talking about this entire side here. This is the hypotenuse, and then the other two sides here are legs. Now, you might not always use both legs in the question. You're only going to use one of the legs and one of the legs' projections, but it depends on what you are given. Let's go ahead and clear this out so we can start fresh. So if AB, and that's this entire value here, is 8, and AC, which is this value here, if that is 4, it wants us to find AD. It wants us to find this right here. Now, what I'm noticing, and I'll do this in blue, this is my leg, right? This down right here, AD, that's my projection, okay? Now I'm going to go ahead and just substitute. So the hypotenuse of my larger triangle, right? And I'm going to put segments first. I didn't do this in the last video, but the hypotenuse of my largest triangle is AB over the leg, right? I'm not going to put CB because CB is not involved in the slightest in this question. So the leg we are talking about is CA. So hypotenuse over leg equals that leg again over that leg's projection. So again, our projection is segment AD. Now if we substitute numbers into here, we would get 8 over 4 equals 4 over x. Now if we cross multiply, we will get that 8x equals 16, and we can divide by 8 on both sides to get that x is equal to 2. So here, we know that AD is equal to 2. Now, a way to double check, right? You can see that this leg and this leg, they're both here. So across, you should have that same number. Maybe if we messed up, we might not have 4 and 4 across from each other here, and that's how we know we messed up. All right, let's get into a different example. So this was an example where we're given the entire hypotenuse, right? We were given that this whole piece here was 8, and we were looking for the projection here. We were looking for the projection. But in the other example, in the next example that we're going to work with, it's going to be slightly different. So let's label what we have. So in right triangle PRT, angle P is 90, which we have labeled for us. Altitude PQ is drawn to the hypotenuse RT, and RT is 17, and we have that PR is 15. So it says determine and state to the nearest tenth the length of RQ. So we are looking for this value here. Now, what's standing out to me, let's double check what we have, right? We have the entire hypotenuse of our bigger triangle, right? So that hypotenuse, I'm going to label that. Now, we also have this 15 is a leg. So we have a hypotenuse, we have a leg, and then we are looking for this piece X here. That piece, QR, is the projection. So it helps just to label this first because there are going to be times where you don't know whether you're using the altitude rule from the other video or the leg rule. So if you start labeling your given information with what the pieces are actually called, it will help you. So our hypotenuse, it would be TR, segment TR over the leg, which our leg is PR, equals that same leg again, PR, over that leg's projection. Now we said that that projection is this piece QR. Now if we substitute, TR is 17 over PR, which is 15, equals 15 over X. Now if we cross multiply, we will get 17X equals 225, I believe that is. And then when you divide by 17, you will get X equals 13.2352, and then it keeps going, but we want to round to the nearest tenth. So our answer here, it would be RQ equals 13.2. All right, now there might be some examples that are a little bit more complex and that are multi-step. So we're going to go over an example like this. In the diagram below, the length of the legs AC and BC are 6 and 8. So what's standing out to me right now is that I have both legs. I have leg 1 and I have leg 2. In the other examples, we only had one leg. So we might have to pick and choose which one we're going to use here. Altitude CD is drawn to the hypotenuse, and it wants the length of AD, which is nice. It's already labeled for X as X for us. Now let's see what we need, though. So for this leg rule, I know I need the value of my entire hypotenuse. I know I need one of the legs, which I have, and then I need a projection. So what's standing out to me right now is that I know that my broken up pieces, these are projections. So this is a projection, but it's not a projection of this leg 2 over here. It's not a projection of CB. It's a projection of AC. So I know right now, just for this, I am going to cross, like I know I'm not going to be using this leg in my formula. So I know I'm using this leg, I'm using my projection obviously, and then I need the value of my entire hypotenuse, which I don't quite have. But what you guys should realize is, hey, this is a right triangle, and I have values of 2 out of the 3 sides. When that happens, you can use Pythagorean theorem to help you find the third one. So we get 6 squared plus 8 squared equals c squared. Now remember that c value is always your hypotenuse. So we get 36 plus 64 equals c squared. 100 equals c squared, and then if we take the square root, we will get 10 equals c. So again, going back to what this means, this is the hypotenuse of my right triangle. So I'm going to fill that in. My hypotenuse now is 10. So now I think I have enough where we can use the leg rule. So I'm just going to put some numbers in. So the hypotenuse of my largest triangle is 10 over the leg that we're working with. Now we're not working with this leg. We are not working with CB. We are working with AC. So 10 over 6 equals 6 over that leg's projection, which is down here, that's X. So if we cross multiply, we will get 36 equals 10X, and then we get 3.6 equals X. So there might be questions where you need to do multiple things. It might not just be like, hey, I'm going to plug this into my formula, but you should be able to use your prior knowledge to help you to get the information you need. Now, at this point, we have been exposed to both the altitude rule and the leg rule. So you have to be able to differentiate between when you're using what, and there might be questions where you need to use both. And maybe it's a multi-step question where you do the altitude rule first and then the leg rule. But in general, you want to think about these things. So does your question involve broken pieces of the hypotenuse and the altitude? So usually that's a dead giveaway. In our other examples that we were just working with, for example, in this question, CD, which is the altitude, is not involved in the slightest. They don't give us a value for it. We're not looking for it. So for altitude is not involved, we are not going to use this altitude rule, right? And again, if you go back to this question right here, again, our altitude was PQ, but we don't have any values for PQ. And X, we're not looking for PQ at all, right? So we know we're not using the altitude there. But if the altitude is labeled and if it is involved, then we're going to use this altitude formula here. Now, on the other hand, what we're doing today, it's does your question involve the leg of the larger triangle? So what I want you to realize is that in examples like this where we're using the altitude rule, notice that the legs, BC and CA, the legs of my larger triangle, are blank and they are not involved at all. That's kind of like a dead giveaway. If your legs are involved, you know for a fact that if they give you information about that leg or you're looking for that leg, like in this case, we're looking for CB, which is a leg of our larger triangle, we are using the leg rule, right? Now, what I want you to also notice, yes, we're given information about the leg, but then also notice that CD, which is our altitude, is not labeled. So that's a further indication, hey, I know I'm using my leg rule there. So you can take a screenshot of this, or excuse me, you can write this down if it helps you. But these slides are on our Google Classroom if you need access to this ever, okay?